electricity is derived from a Greek word, okay? And that Greek word is nothing but electron, which means amber. Conductors are the one which conducts electricity. Semiconductor acts as a conductor, or sometimes it acts as an insulator also. You have got two poles, plus, plus, minus, minus, but they never attract. In fact, they repel each other. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram School of Excellence, welcoming you all to the session 1 of chapter 1, and chapter name is Electric Charges and Fields. So here we are talking about introductory part of this chapter. So we know that in your daily life, you have seen the comb as well as the TV screens or a winter sweaters, that is the winter clothes. It just attracts certain objects, right? When you just go and just stand in front of a TV screen, what happens? You get an attraction feeling from your hand to your screen, correct? So that is all about certain attraction. So what is responsible over there? What is it exactly generated between that space? And that will be the electrons. So here we are introducing something about the electricity, and here what is the cause for electricity? That is the electric charges. So when you just keep the hand or your body, when you just go and stand right in front of a TV screen, it starts attracting your skin. So you can just feel it, and that is due to the presence of the electric charges. And these electric charges are of two types, positive and negative, and these are the ones which are responsible for your electricity. So here you can see an image of the one wherein a comb is shown here, and the comb attracts certain paper pieces, and that is due to the electric charges which is present. Similarly, you can just take TV screen as an example and winter clothes as an example. Okay, so these will be the examples for your electric charges which is created. And even when you just comb, when a plastic comb, when you comb your hair, what happens to the hair? Just if your hair doesn't consist of any oily matter, your hair follows the comb. That means wherever the comb moves, your hair also moves there, right? So that movement is nothing but just the attraction of one object from the other object, and that is also due to the electric charges which is present. So these are all due to the term called electric charges. So how did the electric charges originate? Like how we got to know that there is presence of electric charges, and these are the ones which are responsible for the electricity. And that is, like we can see here, electricity is derived from a Greek word, okay? And that Greek word is nothing but electron, which means amber, okay? So electron is a Greek word which means amber. So what is meant by amber is your question. So amber is nothing but a brown stone. You can, in a jewelry making shop and you can see just a brown stone. On rubbing the brown stone on the silk cloth, there was a electric charges which was generated, because of which this term has come. So amber is a basic foundation for whatever electricity. Now what are we looking at? Okay, so electric charges, electricity, everything has got some basic concept, and everything started because of one object, and that is amber. So amber has a Greek word which means to say it is electron. So you can see the spelling E-L-E-K-T-R-O-N is said to be the electron, which was later concised to a word called as electron, which we are using now. So this is one of the main component which is responsible for electricity. So the next point is the charges are responsible for electricity. So how many types of charges are there? There are two types of charges which is known as positive and negative. So there are positive charges and negative charges. So charges are said to be positive, negative, which is given in the third point over here. Then, if an object possesses electric charge, then the object is said to be electrified or it is charged. Correct? So, suppose you're rubbing the silk cloth upon the amber. When you just rub the silk cloth on the amber, you can say that there is presence of electric charges, that is electric charges are created over there. So you can just say that the silk cloth is electrified, or else the silk cloth is said to be charged. Same thing goes with your TV screens or winter clothes or whatever example I had taken in the previous slide. The same thing also, if it carries a charge, either positive or negative, either all together, then it can be called as it is electrified, or else it is charged. So that is all about your electric charges. And then when there is no charge, it is said to be electrically neutral. So there is positive, there is negative, and there is neutral charge as well. Okay, so positive means it's positively charged, negative means it's negatively charged, neutral is the one which is not having either of the charges. Okay, so now here this is all about the just introductory part wherein you will have to know, and it will be very useful for your further chapters in this second PUC. Okay, so you will have to mainly concentrate on the basic concepts of the certain chapters. Okay, so here we are studying about electric charge, wherein I had told you there is positive, negative as well as neutral. And now it's like there is certain objects which are said as conductors, insulators and semiconductors. So conductors comes first, semiconductors and insulators, that is conductors are the one which conducts electricity. Semiconductor acts as a conductor, or sometimes it acts as an insulator also. So what is this insulator? Insulators are the object wherein there is no passage of current. So it doesn't generate any sort of electricity. So you have got your conductors and insulators with us right now, wherein the semiconductor itself has got its own chapter. Okay, that will be your last chapter, chapter 14. There you can study deep about semiconductors. So now what's there in our hands? It is conductors as well as insulators. So here conductors and insulators means the one which conducts electricity, conductors, the one which doesn't conduct electricity is insulators. So materials that allow the electricity to flow through them easily is known as conductors. Okay, vice versa, that is the opposite of this conductor, the material which does not allow the electricity to pass through it is known as insulators. So here in this conductors, electrons are very much responsible to generate electricity, wherein insulators, electron doesn't move freely. There is no free movement of electrons in case of insulators. Later, this property of a conductor which allows the material to conduct electricity is known as conductivity. Okay, conductors has got different definition. Conductors means the material which allows the electricity to pass through it. So what is this conductivity? It is the material which conducts electricity. You can say this material possesses certain level of conductivity. Okay, it is a level of conductivity which a certain material possesses is known as conductivity. Clear? So that is all about your conductors and insulators. So now you can get too many examples of conductors and insulators on further studying this chapter. So here we have, when you got to know how did the electrons origin, that is the one which is responsible for electricity, electrons origin. That is Thales of Miletus. He just rubbed amber with the silk cloth and he got that there is a presence of a charge, because of which these charges were introduced, and you got to know how many types of charges are there. After that, we studied how exactly the charges behave and its conductors, insulators properties. Now let us study the basic actual rules of the charges, the basic property, how exactly it works. If we get to know how exactly it works, it's very easy for us to go on with the further definitions or numericals or anything as such. So now here we have basic properties of electric charge, which is one of the most important question. Okay, so what is this basic property of electric charge? Here the like poles and unlike poles. Like poles means, see, for something to be attracted, how can you say that an object is getting attracted? That is only when there are two different bodies. When there are two different bodies present, we can say that this object attracts this object, or this one attracts the first one, correct? So it is like how we relate, correlate and give the properties. So here also, in order to relate these properties, we need to have two charges. Either it can be same charges. So plus plus or minus minus, this is like poles. These two are poles, so you can say like poles because both the signs are same. Plus attracts plus, minus attracts minus. Is the sentence right? No. You have got two poles, plus plus minus minus, but they never attract. In fact, they repel each other. Okay? Unlike poles, that is, one is plus and one is minus and one is minus and one is plus. When this is the case, these two are unlike poles. Unlike poles attract each other. So what is the main rule? What you know? And it is a very easiest rule. You can hear it throughout. Maybe you might be knowing also. So it is like poles repel each other, unlike poles attract each other. So that will be your first point. Like poles repel and unlike poles attract each other. So that is all about your first point. Coming to the second point, there are two types of electric charges. Remember, two types of electric charges is one is plus and one is minus. Positive charge and other one is negative charge. When you have two like poles, it repels. Two like poles, repulsion, and no charges, it is neutral, and two unlike poles, it attracts. So it is very easy to understand for you how exactly it undergoes. That is how exactly the charge behaves with the other charge of its same sign or of the different sign or of no sign. So next is electric charges has got magnitude but they don't have any direction. So that is, we don't know in which direction the electric charges are flowing, but we know what is its value. So that is what it is given over here. The charges has magnitude but it doesn't have any sort of magnitude. So electric charges, we are not talking about electric field or something. This is all about just the electric charge. Okay, we don't know its direction but we know its values, either positive value or negative value. With certain value it will be present. Okay, so next is charges are additive in nature. We can add n number of charges altogether. That is, we can just sum up all total, that is n number of charges can be totaled up. That is, if suppose the charge is represented by Q. Remember, the charge is always represented by Q. Q is the representation of the electric charge, either positive or else it can be negative, any value. So when it is charges are additive in nature, you can just give it as, if you have Q1 charge, Q2 charge and Q3 charge which goes on till Qn charge, you can just add all these charges like Q1 plus Q2 plus Q3 goes up till Qn. So these charges are said to be additive in nature. That means we can just sum up the whole charge together. Clear? After which we have charges are conserved. Okay, so charges are always said to be conserved. So what is this charges are conserved? You have heard about the principle of conservation. So in that principle of conservation, we have clearly studied that according to this conservation law, the energy or the charges cannot be created, it neither can be destroyed, but it can be transferred from one form to the other. There is no creation, no destruction, but the charges can be transformed from one form to the other is all about this charges are conserved statement. Lastly, it is charges are quantized. So what is this quantization? Quantization, according to the principle of quantization, the charge is equal to, how is the charge defined as per the quantization? It is like the free electrons, the free moving electrons are said to be integral multiples with the basic unit of a charge, and the basic unit of a charge is said to be, the value of the basic unit is 1.6 into 10 to the power of minus 19 and coulomb. Charge is always represented with the help of a coulomb, where you will be studying it later. So charges are quantized, means according to the principle of quantization we have Q is equal to N into E, that is integral multiples of a basic unit of a charge. And what is the value of basic unit of a charge? That is 1.6 into 10 to the power of minus 19 coulomb. So N can be either 0 or positive or negative, because it is a integer. Integer can be either negative, 0 or positive. So that is all about the basic properties of the charge, and I want you people to study this basic property of the charge and understand it clearly. So again, getting back to the basic properties of charge, it is like poles repel each other, unlike poles attract each other. So there are two different types of charges, positive, negative, and the one without any charge is neutral. Then electric charge has got magnitude and it is represented by Q, and electric charges are additive in nature. They are said to be quantized as well as they are said to be conserved. So we have studied regarding there are different types of charges, positive, negative and neutral. So along with that and conductors and insulators, we study some concept about earthing. So what is meant by earthing? Yes, earthing means suddenly what thought comes to your mind? Earth. That means you're absolutely right. You have got the imagination power, and that is always about the electricity, whichever is said to have electric charges within it, is responsible for any sort of instruments to be worked on, correct? So these electric charges flows from our body as well, and it is said to be grounded. So electric field is said to be grounded in such a way that it acts as a shock absorber, okay? So this process of sending the electrons, that is the electric charges through the body to the ground, is said to be known as earthing, so that the further events can be neutralized without giving any harm to the apparatus or the body. It acts like a shock absorber. So when there is a short circuit or something, it will be earthed. That is, earthing is being done, which will absorb all those events. That is, the events are said to be neutralized. That is why the earthing is most important. The wire is connected to the earth so that flow of charges is from the circuits through the body. By this, they can neutralize the charges, okay? So that is all about your basic properties of electric charge and properties of electric charge. And now we are moving to Coulomb's law. So what exactly is Coulomb? Coulomb means it is all about the SI unit of a charge, okay? So Q, charge value, if suppose this is Coulomb and Q is some charge, it has got its SI unit said to be Coulomb. So SI unit of a charge is always Coulomb. So what law did the Coulomb give, keeping two charges with him? So it is said that suppose if this is charge Q1 and this is charge Q2, which is separated at a distance called as R, how exactly he has given. So I told you while talking about the basic properties of this electric charge, there are two charges has to be there. Whenever you're talking about some properties or something, you're just considering any two, because by considering one object with the other object, we just see the differences and then we start giving the properties, correct? So here we have two charges. So what did Coulomb do? He just took the two charges, and having those two charges, he gave a beautiful statement. And what is that statement? Only focus on this diagram, and it is separated by certain distance r with the two charges Q1 and Q2. So when there are two different objects, that is two different charges, because he is talking about only about the charges. So either they will be attraction or else will be repulsion, because we don't know whether the charges are positive or negative, or like charges or unlike charges. What it is, we exactly don't know, okay, like or unlike. So you can just give the statement as. Finally, what you need, it is just magnitude, that is a value. So each and every law is only used to get the values, okay? In order to get that values, so the one who proposed the law or the statement, they will create one statement in such a way that it will be like matching with each other, correct? So they have to have a formula. In order to have a formula, they need to set up a statement, correct? Like how you do. So here there are two charges and there is a distance, that is r, and it is like the magnitude of electrostatic force of attraction or repulsion. We don't know either we are talking about attraction or repulsion. So, the magnitude of electrostatic force of attraction or repulsion. It can be attraction or repulsion between two charges. Which are those two charges? Q1 and Q2. And that Q1 and Q2 charges are known as stationary point charges. Okay, we are considering two stationary point charges, and two stationary point charges are nothing but these are the point charges whose size is very much negligible when you compare it to the distance. So it's very small. Point charges are just a single point, okay, which is neither having area or volume. So here the force of attraction or repulsion between the two stationary point charges is directly proportional to the product of magnitude of the charges, that is the value of the charges. We don't know the value, so simply write Q1 and Q2, magnitude of the charges, and inversely proportional to square of the distance between them. So inversely proportional to square of the distance. Distance is mentioned by r, so distance between them. So that is all about your Coulomb's law. So force of attraction or repulsion between the two charges, that is the stationary point charges, is directly proportional to product of the magnitude of two charges and inversely proportional to square of the distance between them. That is all about your Coulomb's law. So removing the proportionality, you just get K instead of alpha, that is a proportionality constant, you just replace it by K. F is equal to K into Q1 into Q2 divided by R square. So this is the equation in order to understand Coulomb's law. So Coulomb's law, if they ask, you will have to give this equation, and you know that K is known as proportionality constant whose value can be K is equal to 1 by 4 pi epsilon naught. So when this is the case, your equation can be written as F is equal to 1 by 4 pi epsilon naught mod Q1 into Q2 divided by R square. So this will be the final formula for you to understand Coulomb's law. So Coulomb's law formula is 1 by 4 pi epsilon naught Q1 Q2 by R square. So epsilon naught value, that is epsilon naught, is known as permittivity, whose value is 8.854 into 10 to the power of minus 12 C square n inverse m minus 2. So that will be the SI unit for this permittivity. So this is the value for epsilon naught, which is equal to 8.854 into 10 to the power of minus 12 C square n inverse m square. So 1 by 4 pi epsilon naught altogether, when you just solve it, you will get 9 into 10 to the power of 9 and inverse of all this SI unit. That is, you have your K value can be written as, that is 1 by 4 pi epsilon naught will be having the value of 9 into 10 to the power of 9. There it is C square, so it can be written as C minus 2. N inverse can be written as just n, and m minus 2 can be written as m square. So this can be the value for the K, that is a proportionality constant. Okay, when you know 1, when you know 4 pi value and permittivity value 8.854, you will just get this as the whole value. Okay, so that is all about your Coulomb's law. I hope you are clear with Coulomb's law, the definition, formula and the constants and the equation. Okay, so now where F is said to be the electrostatic force of repulsion or attraction, Q1 and Q2 are the two charges, that is two stationary point charges. R square is the distance which separates 2 point charges. Okay, that is how you explain by using the terms of this formula. Next is Coulomb's law in vector form. So here we just consider the vector form. For that we consider a plane, maybe a 3D axis, x, y as well as z axis. So we have x-axis, y-axis as well as z-axis. So here let us consider 2 point charges. From here this is the origin. Here we have 1 point charge Q2 and here we have other point charge Q1. So it is separated by certain distance here. This is R1 is the position vector from origin to Q1 and R2 is the position vector from origin to Q2, and we have F12 vector, F21 vector, R21 vector. So this is all about the Coulomb's law in vector form. So how do you exactly find out what exactly is lying here? So you know that when there are 2 point charges known as Q1 and Q2 are the 2 point charges which is separated, which is placed at a distance R2 from origin. That is, Q2 is placed at R2 from origin and Q1 is placed at R from origin, and you have got certain distance between them, that is R21 is the distance, and there are two forces which is acting like opposite to each other. So let us just mention the point charges places, that is A and B. So you have AB leads Q1 to Q2. You can write it as R21 vector is equal to R2 minus R1 vector. Similarly, BA leads Q2 to Q1, so it becomes R12 cap is equal to R1 vector minus R2 vector. So this equation, that is, you have got your two equation, this and this. So the second equation is the opposite of the first equation. So you can just write therefore R21 cap is equal to minus R12 vector. So these are the vectors. R21 vector is equal to minus R12 vector. So now the force on Q2 due to Q1, let us write it as F is equal to 1 by 4 pi epsilon naught. So here it is the vector force. Force is always said to be a vector quantity, okay, because it has got mass into acceleration, and acceleration is always a vector quantity, okay. So 1 by 4 pi epsilon naught mod of Q1 Q2 divided by R square, and you have force on Q2 due to this Q1, so it is R21 cap. Okay, so you might think R21 cap, why is that? So R cap is always because here it is a vector quantity, and here if you suppose you don't take the vector quantity, then these many values are said to be scalar quantity. In order to balance your right hand side as well as left hand side to the vector quantity, you just take R21 as a cap. So what is the value of R cap? So it is like R21 cap is equal to R21 vector divided by R21. Similarly, R12 cap is equal to R12 vector divided by R12. So that is all about your R cap value. Okay, so the vector form as well as magnitude form, this is how it is. So here you have got force on Q2 due to Q1. Similarly, you can just give F If this is F1 and this is F2, you have got 1 by 4 pi epsilon naught. The force on Q1 because of this Q2, force on Q1 due to Q2 can be given as Q1, because since it is a product, I can just write same thing divided by R square, and here you have R12 cap. So here we have R square and R square. So this R square is nothing but R21 square, because it's like Q1 acting upon Q2. So we have along this position R21 vector, and similarly Q2 acting upon Q1, that is negative of R21. Negative of R21 means it is opposite, and that is nothing but R12. Okay, so here we have F2 is equal to 1 by 4 pi epsilon naught Q1 Q2, here 1 R12 square and R12 cap. So this is these are the unit vectors which are just used to balance the vector form of any equation. Okay, so I hope you are clear with the Coulomb's law in vector form. And next let us go to the unit charge. So what is meant by a unit charge? So unit charge means the same concept you are supposed to take, that is Coulomb's law, and we have to mention what is meant by a unit charge. Unit means it's 1. So what is a Coulomb's law? F is equal to 1 by 4 pi epsilon naught, that is the expression Q1 Q2 by R square. So we know the value for this, that is 9 into 10 raised to 9, and we don't know the value for Q1, Q2 and R square. So we are talking about unit charge. That means the charges is said to be 1. So Q1 is equal to Q2, both are 1 coulomb. 1 coulomb is their charge. And R square, that is R is equal to 1 meter, because we are talking about unit charge. Everywhere we have to put a standard value, that is 1, wherein 1 by 4 pi epsilon naught, that is a constant term, 9 into 10 to the power of 9. So unit charge is a charge when placed at a distance of 1 meter. It's given here from another. So there are two charges, Q1 and Q2. So its distance is said to be R, which is equal to 1. So the unit charges is a one which is placed at a distance of 1 meter from another of equal and similar charges, that is 1 coulomb. This is also 1 coulomb. This is also 1 coulomb. In vacuum condition, where there is no presence of any air, in vacuum condition, it experiences an electric force of repulsion. What does it do? It experiences either force of attraction or force of repulsion. I told you in general in Coulomb's law. But here they have given electric force of repulsion. And why that repulsion is there? Because they have mentioned similar charge. That means either both will be positive or else both will be negative. It's a similar charge. That is why there is a force of repulsion of 9 into 10 to the power of 9 Newton. How is that? That is all because of you have got F is equal to 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power of 9, and you have got your charge Q1 Q2 divided by R square. Everything is like 1 divided by 1, so it is always 1. So what remains is F is equal to 9 into 10 to the power of 9 Newton. Okay, so the same thing is given here. This concept is known as unit charge. So if you know the Coulomb's law, it's very easy for you to define a unit charge. Unit means 1. You're talking about one value, that is the magnitude of the charges, 1 coulomb. Both the charge also it's a similar, and it is separated by certain distance, and that distance is also 1 meter. Now lastly, let us move to the force between multiple charges. It's like force between multiple charges. For each charge there is force, correct? Q1 acting upon Q2, again Q2 acting upon Q3. There are n number of charges, wherein I had told you that the charges are additive in nature. That means from the start till the end, the charges like 1 to n number of charges are present. Okay, so here according to the principle of superposition, the force on one charge due to number of other charges is what? It is the vector sum of sum of, it is a vector sum of all forces on that charge due to the other charges taken one at a time. We just can consider any one charge at a time. So Q1 is acting on Q2. Again, Q1 is acting upon Q3, like that. Like two charges are responsible for their forces, correct? So one charge acts on the other charge. So like each acts at one at a time, correct? So that is all about this principle of superposition. So what does it say? The force on any charge. The force, it can be on any charge due to number of other charges. On one charge, the forces exerted from the all other charges is the vector sum of all forces on that charge due to other charges which is taken one at a time. So how can you give this? So suppose if we consider the force acting on Q1 due to Q2. Okay, acting on Q1 due to Q2, you can just give it as F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R1 2 square R1 2 cap. Okay, vector form. Similarly, the force acting on Q1, that is due to, let me consider this as due to Q3, then you have F is equal to 1 by 4 pi epsilon naught Q1 Q3 divided by R13 square R13 cap. So this has got a additive in nature, so it can move till n number of forces. So when you just add all this, that is if this is F1 and this is F2, you can just add it as F is equal to F1 plus F2. You add those two equation as, and it goes up till Fn. It can take up till number of other charges. So it can be given as 1 by 4 pi epsilon naught Q1 Q2 by R12 square. This is for the first force. Second force, and it is mentioned as R12 cap, and 1 by 4 pi epsilon naught Q1 Q3 by R13 square R13 cap goes up till 1 by 4 pi epsilon naught Q1 Qn divided by R1n square 1n cap. So this is the continuity form of this force between multiple charges. So this can be given in one equation, and I'll write this equation above here. The total of the force, that is force which is acting between multiple charges, can be summed up, and it can be given just in a single equation, that is capital letter F, force. F is equal to sum of. Before the summation, I have to write certain terms which is very common throughout. So it can be 1 by 4 pi epsilon naught because it is repeated, and Q1 is the one which is repeated, correct? So I can write these many things out. So Q1 divided by 4 pi epsilon naught. This is the one which is very common throughout, and which is the one which changes, that is Qi divided by R1I square into R1I cap, where I is the one which keeps on variation from 2 to n, because 1 is already here Q1 and the next term itself is Q2, so it is 2 to n. So that is a general term for you to represent force between multiple charges. So I hope you are clear with these many topics which we have cleared today in this session. That is the first session of the chapter 1, electric charges and fields. Let us all meet in the next class in the upcoming more interesting sessions from the same chapter. Until then, have a good day. Thank you.